What if humans used 100% of their brain? The truth might surprise you. Imagine waking up tomorrow with a brain that suddenly works at 100% capacity. You can solve complex math instantly. You remember everything you've ever seen. You learn languages in minutes. Your reflexes are superhuman. Sounds incredible, right? Movies like Lucy and Limitless suggest humans only use 10% of their brain, and unlocking the rest gives you godlike abilities. But here's the twist. That famous 10% of the brain idea is actually a myth. In reality, your brain is already using almost all of its regions, so the real question becomes even more fascinating. If we already use our whole brain, what would happen if it worked at its absolute maximum potential? Let's explore. Part 1. The 10% brain myth. The idea that humans use only 10% of their brain has been around for over a century. It's often mistakenly linked to the famous psychologist William James. But he never said that we use only 10% of our brains. Modern brain imaging like fMRI scans shows that different parts of the brain activate constantly depending on what you're doing. Even when you're resting, your brain is busy running something called the default mode network. Your brain is incredibly active. In fact, the brain makes up only 2% of your body weight, yet it consumes about 20% of your body's energy. That's an enormous amount of power. If 90% of your brain were useless, evolution would have gotten rid of it long ago. Scientists studying the brain, in fields like neuroscience, know that almost every region has a specific function. Damage even a tiny area, and serious problems can occur. Which means something important. Your brain is already operating close to full usage. But that doesn't mean it's operating at maximum performance. Part 2. Your brain's real limits. Think of your brain like a supercomputer. It's powerful, but it has limits built in for safety. For example, your brain processes information through around 86 billion neurons. These neurons communicate through electrical signals and chemicals called neurotransmitters. But if all neurons fired at maximum intensity all the time, the result would be catastrophic. In fact, something similar happens during a seizure, like those experienced in epilepsy. During a seizure, large groups of neurons fire uncontrollably. Instead of gaining superintelligence, the brain becomes overwhelmed and loses control. Your brain is designed to balance efficiency, stability, and energy use. Think of it like a car engine. Running at maximum RPM constantly would destroy it. So, evolution designed the brain to operate in controlled patterns, activating different regions when needed. But now let's imagine something different. What if we could safely unlock maximum brain efficiency? Part 3. Perfect memory. One of the first changes would likely be dramatically improved memory. There are rare individuals with a condition called highly superior autobiographical memory. They can recall almost every day of their life in extraordinary detail. One famous example studied by scientists is Jill Price. Ask her about a random date years ago, and she can tell you exactly what happened. But surprisingly, this ability can be overwhelming. Imagine remembering every embarrassing moment, every mistake, every painful memory. Your brain normally filters information to protect you. Forgetting is actually a survival tool. If humans had perfect memory, our minds might become overloaded with details. Part 4. Extreme intelligence. Now imagine something even more dramatic. Your brain begins processing information much faster. Complex problems that once took hours now take seconds. You might think like the greatest minds in history, such as Albert Einstein, Isaac Newton. But here's something fascinating. Studies of Einstein's brain found that it wasn't necessarily bigger or more used than normal brains. Instead, certain regions were structured differently, improving connections between neurons. This reveals something important. Intelligence is less about using more brain and more about how efficiently neurons communicate. In other words, better wiring, not more power. Part 5. Superhuman senses. If the brain processed sensory information more efficiently, our perception could change dramatically. Right now, your brain filters massive amounts of data. For example, your eyes receive millions of bits of visual information every second, but your brain throws most of it away. If it didn't, you'd be overwhelmed. But imagine a brain that could process everything simultaneously. You might notice tiny movements others miss, distant sounds, subtle emotional cues in people's faces. Some scientists believe savants, people with extraordinary abilities in areas like music or math, may have brains that process certain information with fewer filters. But again, this often comes with trade-offs. The brain's filters protect us from sensory overload. Part 6. The energy problem. Here's the biggest obstacle to a 100% maximum power brain. Energy. Your brain already burns enormous energy. If its activity doubled or tripled, your body might not be able to sustain it. The brain relies heavily on oxygen and glucose. Without them for even a few minutes, brain cells begin to die. So a truly maxed-out brain might require a faster metabolism, more oxygen, possibly even changes to the human body itself. In other words, humans might need to evolve into something new to support that level of brain power. So, what would happen if humans used 100% of their brain? The truth is, we already do. But not all at the same time, and not at maximum intensity. And that's probably a good thing. Your brain isn't limited because it's weak. It's limited because it's carefully balanced. Too much activity could cause seizures, sensory overload, extreme energy demands. The real power of the brain isn't unlocking hidden areas. It's improving how the brain learns, adapts, and connects. And even today, scientists studying the brain are still discovering just how incredible it really is. Which raises one final question. What if the real potential of the human brain isn't using more of it, but understanding it better?